So about us. So ehsInc, we have been a firm since 1997 specializing in occupational health and safety consulting and training services. So what does that mean? We pretty much cover all four corners of the regulations. When it comes to consulting, it may be, albeit air monitoring, job hazard analyses, industrial hygiene assessments, things of that nature we can do for you folks. And we're going to cover some of those components in today's presentation. We also do that very important subsequent employee training. So if you guys know it, you guys all know that if it's not in writing, that it doesn't exist. So we'll tackle that part of it first, which is a written program, and then we'll give that subsequent training. So that's pretty much us in a nutshell. I don't want to take Roy's time here. About the presenter, he'll talk to you guys about what his credentials are, but it speaks for itself. He's been with us for what, 14 years now, Roy?
Yes, that's correct.
And he's our go-to guy. He's our senior safety specialist. So he's very well versed with applicable regulations, and like I said, he holds a CHST in construction. So that's a notable certification there. Oops, one second. And one last thing before I pass the baton to Mr. Horta, you are getting credit for one contact hour. So for those of you that hold accreditations or certifications or have acronyms, I would, it'll behoove you to go visit that URL. It's ehsinc.org/CEU contact hours. Look and see what firm we are accredited through to provide safety contact hours. That way it's worth your time for today's webinar. All right, so that's it for me. Again, chat menu, questions to me specifically, Q&A, will hold those queries towards the end of the presentation. Roy, it's all yours, man.
Okay. Good morning to all of you guys today. This is beautiful Friday. So this is one of those new, not new regulation, but it's a regulation that it's been on the making for like since the 1930s. When first was OSHA knew that the silica was actually a problem. And so now, and then in 1971, we decided we wanted to do something about it, and then we created a standard, and we set some limits. So after that, since 1971, we have a major overhaul of the silica rule, and we changed the concentrations again. So that's the importance of this. And when we change concentrations, it's because we know that something is actually maybe our standards are not up to par with the amount of illnesses that are actually happening in the field. So the first thing I would love to talk to you guys about is the abundance of this material on the planet. So when we talk about crystalline silica, most of us we think it's like, oh, come on, really? I have this from some of my students on the classes. They said, well, why now? Why now we suddenly start figuring it out that the silica is bad? And obviously, silica is only produced when we work, when we cut concrete, or when we grind, or when we do different types of work with different materials. But that's not really the case. This is a very abundant material on the planet. So about approximately 50% of the Earth mass is actually composed of some form of silicon type of material. So the reality is it's everywhere. It's everywhere. But we make it worse when we actually work with it, when we actually create the dust. So as long as it's been there, sitting there in the ground, and it's not moving, it's perfectly safe. The problem is we create certain conditions which actually make them airborne, and we have them suspended in the air, and people working and walking around the area will actually be taking this into their lungs. So according to some of the statistics, shows about 2 million workers in construction are exposed to crystalline silica by drilling, cutting, crushing, grinding, and doing a lot of different activities in the construction industry. So OSHA decided that, you know what, maybe it's time to do something about it. We have enough data, we have enough information on how we are going to actually fix this, and they reduce the permissible exposure limit of this particular material down to 50 micrograms per cubic meter. So if some of you guys were already part of the industry, or maybe you're new to the industry, or maybe you are just learning about this, the previous standard was actually the permissible exposure limit was 250 micrograms per cubic meter. So this is a significant cut on concentration, which it makes a lot of companies a little bit nervous because they feel they're not going to be able to comply with it. But OSHA also, it's giving us a little more information than just cutting the concentrations down to 50. They're actually giving us some ideas on how we can actually control the production of this particular material. So let's go and look at what are the rules. So in case you want to learn a little bit more, you can either contact us and we will be able to actually set you up with a class or do something else for you. But if you, at the moment, you would like to look at the regulations, these are some of the regulations. They actually cover your silica, 29 CFR 1910, 94, 1910,000, Table Z3, mineral dust, that's for general industry, construction, 1926-55, A and 57. There's some of them. And so you can actually go directly to the OSHA website and read a little bit more extensively about this particular problem. So the final rule, just a quick overview. Like I mentioned earlier, we're going down to from 250 micrograms on the construction industry down to 50 micrograms per cubic meter, for permissible exposure limit on a TWA in a 8-hour period. In other industries will be a little bit different, and some industries will be like just maybe half, including your general industry. So it went down significantly from it get down to an actual level of 21 micrograms per cubic meter for general industry in certain occupations. So another one is to, and this is where OSHA actually created a little bit of, I'd say a lot of help by actually giving you some options in engineering controls. So how are we going to control this? How are we going to limit the worker exposure to this particular contaminant? And so you have different things. So if some of you guys are familiar with the regulation, we have something known as the table. So when you go to the regulation, you'll see what is known as the table 1, and that will give you a specific exposure control methods when working with materials containing crystalline silica, which basically will tell you exactly, like if you can do, maybe an engineering control like water control or HEPA, a vacuum system, and if you cannot comply with that, then they give you options on different types of respirators. So that's also really important. So this is not just a regulation when they just said you need to lower the concentration. They're asking you to, they're actually giving you a little bit of help trying to figure out how to control it. So especially for small businesses. So let's see, I'm trying to control here with PowerPoint. There it is. So these are some of the effective dates for this, which already some of them were already passed. Construction industry was September 23rd, 2017, which is like last year. And then there was some legal issues. This thing was fought in court, and but it will stand as it was. But now they moved into general industry and maritime and to June 23, 2018, and hydraulic fracturing is June 23, 2018 for that particular industry. And I believe they changed also some of the numbers, the dates on compliance for some of this materials. So give me a second. So right now for construction, like I said, it's already set and done. So you're in. So you have to comply with it. So what is it you need to do to comply with this? Well, first of all, you have to create a program, and also during that program, you actually have to do some training. So you have to really understand what Silica actually does, and so you can transfer this to your employees. If you're a small firm, it's always good to, try to find help through us or just visiting the OSHA website. And then so try to get just enough information just for you to be actually properly informed on what's going on. So this is some of the health effects of silica. So some people actually call silica the new asbestos. It's just a little bit different what it does to you, but it's also very troubling. It's hard. It's an illness that is going to hurt you. So we're in the business of protecting people, and that's what this is all about. So if you look at this, they have a picture of two different lungs. There's a healthy lung and a lung with silicosis. It's a very debilitating illness. It's fatal once you're diagnosed with it, and then it's not that long that you're going to leave. So this is something that has to be prevented. It's not something that can be cured. It has to be prevented. So we got to do something about it. So some of the signs and symptoms of silica. So besides the lung damage, it produces fibrotic nodules inside, and it's carrying around the silica particles. So your body is trying to help you by actually trying to keep that material from continue traveling through your body. So what it does is try to fight it, and actually what it does, it causes scar tissue in your lungs. So I have a family member that actually died of something very similar, and it's just a sort of horrible illness. So the doctors, they call them leather lungs, because they get hard, they get solid, so they doesn't allow the lung to actually expand. So some of the symptoms will be like shortness of breath. They have a very hard time actually, like moving. They get fatigued. They get a lot of coughing, loss of appetite, pain in the chest, sometimes fever. Some of these things are actually treated with antibiotics and oxygen. So we have three types of silicosis, which we have a chronic, acute, and accelerated silicosis. So chronic, a lot of you guys, if you're safety professionals, you know what they're talking about. It's a long time. It takes several years, 10 or more years for the exposure of the silica to actually cause an effect on your system. So very low concentrations. Accelerated, this is an interesting one. It's a high concentration of crystalline silica and develops from between 5 to 10 years. This is accelerated. And but acute silicosis, this actually can happen within a few weeks and between few weeks and 5 years. This is a really high amount of silica dust that, like, you gotta be swimming on this stuff actually. This is an amazing amount of silica. Demolition of a building can produce that, something that actually is really extremely large. So some of the illnesses that are developed through silicosis, it might be your COPD. You probably see that on TV a lot. The chronic obstructive pulmonary disease, this is another one that actually it's very common. You watch TV and you see those commercials when the gentleman cannot play with their kids or their grandkids because they cannot actually breathe properly. So chronic obstructive pulmonary disease is actually a combination of, so they can have a lot of different things like chronic bronchitis, emphysema, bronchiectasis, and chronic airway obstruction. And according to statistics, by the year 22, it's projected to become the third most common cause of death in the world. So there's a lot of interesting numbers. I have a lot of numbers here now, some notes that I took. But let's talk about a really large, let's see if I can give you some of these numbers. It says in 1999, COPD ranked as the fourth leading cause of death with over 124,000 deaths. And it says although death rates for COPD have declined among U.S. men between 1999, 50% per 100,000, and in 2010, 40.76% for 100,000. In the United States, there has been no significant change. among the rates of this because we're trying to control it. We're doing something about it, but worldwide and in other countries where they don't have laws and regulations as we do, the numbers keep rising. So, so it's important to, if you have any of these symptoms and you've been working with Silica for many years, you work in the construction business, you go check your doctor, make sure you're okay. It's important if you catch them on time, it will be able to be managed, and it might be able to keep you healthy for a long time. So something you do when you go to your doctor, if you make sure that when you see your doctor, make sure you explain everything that you're feeling and you're having. So some of the stuff they do to try to see if you have any issues is by x-rays. So you got to check your x-rays, see if there's anything in it. They're similar to asbestosis. X-rays will one of the few things that actually show them on your lungs. Pulmonary function test, if you ever use a respirator, is a little test that you do when you go to the doctor and you blow out through a tube and you got to keep the little bulb floating for a certain amount of time to give you the capacity of your lungs. That will actually help you show how bad is your function, your pulmonary function, and also evaluation for tuberculosis. So this one, if you have they assume you have silicosis, this is something they can actually use to diagnose the damage to your lungs. So, as everybody knows, there's no really treatment for silicosis. There's no cure. So one of the things that you're not supposed to do is just to, once you're diagnosed with silicosis, you got to stop the activity that's actually causing it. So you got to remove yourself from, you know, whatever job that you're doing that is causing the issue. You got to remove yourself from that because it will make it worse. Also, it's something that I know. Sometimes I don't like to talk about this in these classes and also in, in these webinars and also in classes is the smoking. Yeah, it's one thing that, my God, everybody gets really upset because it's like, oh, come on, you know, like I really like this, my bias. I say, yeah, well, it might be, but in these situations, it's not something that you really want to continue doing because it will actually cause a lot of irritation of your lungs too. Other treatments will be antibiotics and or treatment for tuberculosis. Some of those drugs will actually will help you out to keep going through your life. Lung cancer screen is another one that will follow after that, just to make sure that your lungs are fine, especially if you smoke, to make sure you're on the safe side. Yeah, so like I said, we keep talking about cigarettes here. I know some of you guys will go like, really? What's wrong with cigarettes? I have them, I like them, it's my right. Yeah, it is. So, but if you're in any activity where like you're exposed to like silica, not only silica, but asbestos or any other type of air pollutant and contaminants, you need to, if you're smoking, you need to actually make sure you check your doctor or maybe quit. So that way you'll be better off without that, because that will aggravate any type of previous illnesses or illnesses that are actually developing inside you without you knowing. So now, how do we prevent this from happening, right? So how do I do, what did I need to do? So if you're looking at the presentation, you see this guy cutting some cinder blocks. You see all the dust that is generated. I showed one of these pictures in one of my classes, and someone said, really? So the dust is not even getting to them. I said, well, that's what you're seeing at this moment. But actually, those particles are actually already floating or getting to your lungs. So this is a very common assumption that if I don't see it or if it doesn't get close to me, if I don't taste it or smell it, I'm okay. But that's not how it works. So you have to always be protected or somehow do an engineering control for this. So these are some numbers from the Department of Labor. There's at least 1.7 million workers in the United States that actually are exposed to silica, and hundreds of these people actually die from illnesses caused by breathing in silica, and a lot more actually they continue to get ill. So there's another little table here where it shows you who's at risk. So if you look to your left of the screen, you see the task, and then to the right, you'll actually see the construction material. So I'll press it. blasting and construction material, asphalt. So there's a lot of different things. So all this is, it's people that work with any of this, and they actually, or have any of these tasks, actually will be at risk of being exposed to that, to the silica. Another activity that is actually very common, it's your sandblasting. So I used to do sandblasting for a company I used to work for a long time ago, and I used to get into a suit. So this thing will have some, it was a positive pressure suit. So basically what it does, you just step in and then the suit actually pressurizes, so you're always completely isolated from the stuff. Actually, people actually sandblasting with just a face shield and safety glasses and a canvas suit. And when I asked why they do that, they said it's because it's a lot faster. This is by the time I put the helmet and everything else, and I've been doing this for 30 years and nothing had happened to me yet. And the interesting word is it's the yet. So it's not if it's going to happen, it's just when it's going to happen. So sandblasting is one of the biggest things that actually produce a lot. And normally we use already lots of people do sandblasting that requires a respirator. You have to have a respirator or a sandblasting suit. But I've seen actually people actually doing that without it, and that's actually very risky. This is one of the operations that actually will produce a lot of this and will be projected through here. So how do we prevent this from happening? Well, what about if instead of just doing an engineering control, we do a hazard elimination? Why don't we get rid of the material? So there's a lot of substitutes. They're a lot more expensive, yes. Some of them they're not that good as a regular silica sand. But there's advantages and disadvantages to the product. So I'll encourage you to look at your process and what you're actually trying to accomplish, and see if you can actually maybe change the material you're using for certain applications. If you're into rock drilling, that's another one. This one is always done on the up end and in certain places where the wind velocity is a lot higher. So if you position correctly, some people say you'll be okay. But again, you have to do an analysis of the air just to make sure that you're okay. Water is always a good friend. And a lot of these operations are just water sprayers or equipment already equipped with the water nozzles will actually take care of that. Every time I see this picture, I always find it, I think it's one of the greatest pictures where this guy is actually standing on stilts and it's actually grinding. So from here, from that picture, from the position of the picture, you cannot really see the guy's wearing or maybe you can't see the guy's wearing a respirator, or he's just wearing a bandana around his mouth. And so, but this is one of those things where you look and you're like, oh gosh, yeah, this is one of the sources of actually getting a lot of stuff into your lungs. This is another one that I love. This one, it looks like he's wearing a respirator. I don't know if he's doing it properly or not. I don't know. I'm trying to see the picture, but this is actually an operation that generates a lot of dust. As you're doing it inside the building. So after you cut or you sandblast or you did anything and you're trying to remove the excess material from the ground, it will actually produce also a lot of dust. Proper engineering controls, and maybe in this case, personal protective equipment or equipment that actually can spray a little bit of water. And there's also lots of material that will actually control the dust by just tossing the materials on top of them. And they will somehow control it and minimize the amount of dust. This is another application where, if you guys are, this is actually done by, it seems like by remote control, but still the person is really too close to it. So dry pavement, dry concrete cutting, it's never a good option. Most of the cutting nowadays is actually done with the equipment actually is equipped with water blasters, so they will actually keep the dust basically to non-existent. So this is some of the this is from NIOSH. This is your TLV, your threshold limit value, and your permissible exposure limit from NIOSH. Is on cement, tile cutting, residential roofing, handheld gas cutters. And this is it's a 0.5 threshold limit value for respirable parts and PEL is 0.1 according to these guys. So look at this. So this is another one. This is interesting pictures. If you go around taking pictures, you will always find some enough material on a lot of different construction sites, regardless of the size of the company. So there's a lot of dust being generated, and these guys are basically just pretending everything is okay. Complacency and working, doing the same activity for many years without getting injured or not knowing anybody that actually got injured, it makes you feel that you are okay and life is going to be okay after. But this is some of the behaviors that we need to control. So, what is the risk of when we work with the silica? One thing we need to do is basically, as we mentioned earlier, and we keep mentioning throughout the entire webinar, is when we control it, the exposure is very low. So that's what we want. We want to control it to the point that it's so low, it's way below the permissible exposure limit. If we don't do that, our concentration will actually get a lot higher, and then will compound if there's several people doing the same activity on the same place. So, and some people said, well, some of the OSHA 30 and OSHA 10 classes, they ask, okay, so what if I just do it for 10 minutes? What if I just do this for 10 minutes every day, and I've been doing it for the next 30 years? Do I really need to wear a respirator? Do I need to use water? Do I need to actually control this with a HEPA vacuum? Well, the answer is yes, because you can actually do this for very few times. Actually, we might generate a very high concentration of the material. And so that's a problem. So now that someone says, well, what if I do it for really, like 2 minutes? Well, still you might actually generate in those 2 minutes enough material that actually breaking the law. So it will be about 50 micrograms per cubic meter. So you got to be very careful about these assumptions and what we know as common sense. Sometimes there's not that common, and some of those assumptions are not good. So what you need to do is you need to stick to the rules and make sure that you are actually compliant with the law, and you're providing protection to your workers. So can we prevent silicosis? Yeah. Don't work on any. Stay away from the stuff as much as you can. But if you can, like proper engineering controls, proper respiratory protection, will actually help you out not to get involved with this particular material, not to get them into your lungs, which is actually what we want. So, like I said earlier, avoid working in dusty situations. Learn more about silica. If you don't see it, it doesn't mean it's not there. Even if you don't see silica is actually still there. So never assume anything. It's always the best thing is to prevent. Prevention. Water is one of the biggest things we can use. It's a lot of saws and drills and different equipment. Actually, yesterday I saw this really cool contraction of how how they vacuum when they're drilling through the walls, and it's incredible. So technology actually has advanced and improved a lot. So there's always something in the market that will actually make your life easier. I know there's always an expense, but at the end of the day, you're sending all your workers or yourself. You're a worker. You're actually going home in one piece. You go visit, go to your family, hug your kids. So you can be okay. So some of the requirements is if you figure it out that you cannot do an engineering control, that you cannot control it by either water or vacuuming, or there's no way for you to lower the concentration, might have to give you a respirator, right? So when you receive a respirator, the respirator is not just for me just to give it to you and then you figure out how to use it. So I have to make sure that I'm giving you the proper respirator for the work, and I want to make sure that you actually know how to use it and you follow all the regulations. If you notice on the presentation, it says something about beer and mustache and all those things. So so you really have to, like I said, in this webinar, it's very limited time, so we can talk about respirators all day. That's something that I love to talk about. So we can go hours on end actually talking about respirators. But just make sure that if you are going to use a respirator, make sure you look for professional advice on how to use it properly, what type of medical test you need, and most importantly is that they have to fit it properly to the person. So you got to do fit testing and everything else that is needed. You have to also have a program. So that's just part of them. Personal hygiene. This is I cannot emphasize this so much in every single class. Not because you don't see it in your body doesn't mean it's not there. And never take it home. It's always that I always tell everybody, don't take it home. And if you're going to go eat, I know sometimes it's hard to find water. Bring your own water. If you know it's hard to find water, you do not feel comfortable with the porta potties and the little water, the washing units. If you don't feel comfortable with that, which is actually they're perfectly clean and you can use them, but if you don't feel comfortable with that, bring your own supplies. But make sure that you're actually clean. And then when you go home, make sure you do not bring that into your car. So if you're full of the dust, change. If you can shower, shower. Don't wear the same shoes you've been using throughout the whole day, like dragging all this dust into your car. You will accumulate a lot of the stuff in the car. So make sure you leave it behind. Don't bring it home. Just leave it there. So I've been talking about engineering controls, and so I assume a lot of you guys already know this, but as a safety professional, we know we have to get rid of the problem, right? So I would rather get rid of the problem or engineer the control in a way that I can properly do the work without using personal protective equipment. My personal protective equipment use should be the last resource. I don't want to use it immediately. That's the lazy way to do it, and it's actually a lot more complex. So if I can control it some other way, by all means, do it. But do not just pretend that, oh, you know what, it's a lot easier to give you a respirator. Sometimes that's not really the easiest route to control what Silica does. So another thing that I notice sometimes when I'm walking out there, when I'm actually driving home, or sometimes close home, there's actually construction going on the street, is that as you're passing by, sometimes you see one guy perfectly fitted with a respirator, and he's doing an activity that's producing some dust, and you got 5 guys around him without respirators. And so what is that telling me? So either I'm going to keep them away, or they're going to have to wear the same personal protective equipment that the guys are actually wearing, or I'm going to have to control it so these guys are not exposed to it. So, but a lot of people don't get that. They think that because they're not actually with operating the equipment, they're actually safe, but that's not really the case. So, so it's important that you emphasize that to your employees. So, so like I said, it's a lot of different ways to control the dust. There's a lot of equipment out there. So just make sure you find that material that actually works for you. It's a lot of different control systems. I've seen them a lot. The dust control for like silica and every other dust that you generate in construction, it's not new it's a lot newer information for construction. It's a nuance now for construction. They feel that it's something that is like brand new for every single business. But in reality, this has actually existed for a long, long time. Most general industry businesses, if you go to factories and places like that, they already have systems that actually do that. They control the dust by using huge vacuum systems and ventilation systems, fume scrubbers, and different things like that. Now, that's a lot harder to do that outside. So the assumption was that because we were out in the open, I don't really have to do this. And we're actually finding out that that's not really the case. The dust is dust, and it actually moves around. Some of you guys already in the construction industry already do that. They actually have these trucks with water trucks that actually go around the area because you got to control the dust. It's actually the same principle. It's the only difference is now you're doing a little more localized. You're doing it just for like a little hole in the ground, like someone says, "Oh, for that little hole, do I have to do all of this?" Yes, you do. And the operative word here is permissible exposure limits. Am I above or below that's what you need to actually analyze first. So this is some of the control systems. So you can see that this guy is actually cutting masonry with a saw, and you see him. The guy is actually fitted with a popper. This is a respirator operated by batteries, a power air purifying respirator, and he also has a collection system, which is actually connected to the cutter. So as you can see the saw is actually fitted with a tube, and in the back of this guy there's a HEPA vacuum, and he's also wearing a respirator. So they double it down. Is this necessary? Well, I don't know. I don't know what the operation is, and I don't know why they're doing it like that. But if it's necessary, yeah, this is actually perfect. So you have to find that works for you and they help you comply with the law. So this is another one that I love it. I've seen this before, and this is actually pretty cool. So you mount it on the wall, you drill, and this will actually suck the materials. They collect the materials into a vacuum. Remember, it cannot just be a regular vacuum. It has to be a HEPA vacuum. A regular vacuum will actually shoot the materials from the back of them. So you got to make sure you actually use the proper materials. Sometimes they use water. I talked to different people in the businesses that I visit, and they said sometimes we don't really like water because actually it created a mess. And it says, but sometimes all we have. But it says, when we find equipment like this, we're very happy because actually we control it in a more simpler and faster way. So there's actually dust capture systems. It's a lot of stuff that that basically has it works. It actually generates. This is if any of you guys are in the like a chemical industry and you have a fume scrubber. This is almost the same concept of the fume scrubber, where the materials coming in and water actually captures the rest of it. So it makes it heavier and bring them down to the floor, to the ground. So that's yeah, this is a cool picture. I've seen places where they have they're doing something like this, and you have a sprinkler system all around them, and actually shooting water on a continuous basis. Just look at this. This is just something we used to do in the past, and it was not a big issue. Because people were never really understood the concept. They never understood that actually it was bad. And like I mentioned earlier, this is not a 2017 or a 2016 or a 2020 regulation. This is actually, I mean, not regulation, I'm sorry, I stand corrected on that one. This is not a problem that just happened 2 years ago. This is something that we knew from the 1930s. There's actually a video from the Department of Labor that opens up with, we know this is bad. We know we need to control it, and but not until the creation of OSHA in the 70s, this actually was tackled in a more proper manner. But now we actually figure out that actually even those numbers were not protecting people enough, so we have to lower those numbers. So you can see in this one how the trucks are passing by and actually trying to control it by using water. So this other type of control systems, I know they're fancy. I know there's an expense when you use stuff like this, but sometimes they actually help you out to, you know, not to put people under respirators and not create a mess and actually comply with the law. And most important than anything is actually send every single one of your workers home in one piece. I mean, it's like, it's nothing more rewarding than you know, running a company where, you know, everybody goes home every single day. They do not have anybody actually getting injured. At the end of the day, that's actually what it makes the day worth. Is to be able to actually send everybody ready to go and enjoy their time off with their families. So these are other examples of waste suppression systems. Material that wants to use water to control it. So, like I said, like mentioned on the previous slide, dry sweeping it's not a good thing. And also people use compressed air. And my God, I don't know how exactly they think they're actually cleaning, because they're pushing to the front, but actually the dust is falling on the back. So when they finish, actually they have to still have to sweep. And not only that, you already got the stuff in your lungs. So So vacuums, and then like I said, there's actually materials that you can actually throw on the ground, and including water. It can actually help you sweep and clean a lot easier and without producing any dust. So before we continue with this, the air sampling analysis, there is if you're not familiar with it yet, you can visit the OSHA website and look at the table 1 on the silica regulation. You'll find it there. So the standard for construction is 29 CFR 1926-1153, and what you're going to see there is table 1, which is specified exposure control methods when working with materials containing crystalline silica. So I'll encourage you to actually go and look at it. Some of you guys already know about this, but if you don't, and this is something you need to visit. So this is an example that I have here in my hand. It says equipment, /task, handheld power saws, any blade diameter, right, between parentheses. And it says engineering and work practice control methods. So they give you what you can actually use. It's a USO equipped with integrated water delivery systems that continuously feeds water to the blade. Operate and maintain tool in accordance with manufacturer's instructions to minimize dust emissions when used outdoors and when used indoors or in an enclosed area. So if I can do the engineering control, then I don't have to do the next one, which the next one is actually says. So if you cannot do any of those two, then you go to the next one. It says require respiratory protection and minimum assigned protection factor, and it has to give you for the operation. It's a 4-hour shift, assigned protection factor of 10, and so they're basically telling you. So if you cannot control it this way, you have to use a respirator. So if you go and you look, you will actually find a lot of information on table 1. That's your number 1 resource. Just for you to make an educated decision. So if you know you have silica on your job site, you got to collect a sample. You got to hire somebody to do it. If you have the ability and the knowledge, by all means, go and do it. So if you haven't done it yet, send it to a laboratory so you can get a sample. I don't know if you've ever seen, probably a lot of you guys have already done it. You get a industrial hygienist, and then he goes to your facility and he connects this little thing on somebody's shirt, a little pump, and you basically, they walk around for 8 hours, and so I want to suggest something, because I know some people, what they do is they ask them to do that in days when you're very low on work, when you don't really have that much cutting and sewing. So you try to mimic worst case scenario. Try to mimic those situations where you know this is going to be generated, so you can actually get an accurate number. Because if you do it in a day when you're not doing any of that stuff, of course you're not going to generate any numbers. So make sure you mimic your worst case scenarios to get a baseline. At the end of the day, it's up to you what you're planning on doing, but it's just a suggestion, and so you can get an accurate numbers. So that you know exactly what you're dealing with. So like I said, just get those numbers and see the reports, and then go from there. So that you'll decide what to do. If you need help, we have a certified industrial hygienist on site. They can be more than happy to actually go visit you and help you out with to do any type of assessment. We can help you out to create your programs. We can help you out with anything that you need. We will generate reports for you. We'll do anything. We have, so we have the knowledge, and we have the experience to actually support your any type of line of work that you do. We would be more than happy to actually provide that for you. So also, you can, like I mentioned earlier, online resources. If you're familiar with the QR codes, just grab your phone, point it at the screen, and then you can actually get a direct link on your phone, or just go to the OSHA.gov Silica, or just do a regular Google search, just Google Silica, and it'll take you there. We also have some other, this is a ORG website. This is www.silicasafe.org. Again, the same thing. You just go directly to the QR code. And also, our good friends from the Center for Disease Control, actually, also your NIOSH, basically your NIOSH. Go there. There's so much information in each one of these things, and I know sometimes it's hard for some of you to actually have enough time to do this, or to actually navigate the intrinsic websites. They have so much information on it. Sometimes you never know when to start. So if you have any, if you need any help, like I said, we're here to help. You can contact us directly, and we'll be more than happy to provide you with any help that you need. Okay, so I think I'm coming almost down to the end of this presentation, and this is the last one. This is also a good place to actually learn a little bit more. Sometimes people, when we talk about illnesses and things like that, we're always trying to find information on NIOSH and CDCs and the CDC and also OSHA or EPA, but sometimes we forget about those associations that actually they do this also. They actually will have an incredible amount of help and support for you guys. So this one of them is the American Lung Association, and you can see they actually have a whole site on silicosis.